Experiment number 5 in the design and analysis of algorithms lab is to write a Java program to perform merge sort on given set of n integer numbers and then demonstrate it by making use of divide and conquer technique. So here we have defined a class called as prog5 which has the main function in it. We have defined the variables like number of elements of the type integer and an one-dimensional array. It's also of the type integer with a capacity to hold almost 10,000 numbers. And then there is a start time and stop time. Start time and stop time both are of the type long because they are supposed to hold the system's current time. And then we have created an variable called as scan which is of the type object of the type scanner class. And then we have created an object called as random which is of the type class random. It is basically used to generate random numbers. And then we have created an object called as msort which is of the type class merge sort. Then the next line asks the user to enter the value of n, that is the number of elements that you want to sort. So it is stored in the variable number of elements. We read it with the help of scanner object. So scan object is going to call next int method to read this integer. Closing the scanner object is optional. So we close it with the help of the function close. So then the next line we ask the PC to generate the random numbers. So the number of elements that is to be generated is already available in the variable number of elements. Thus for loop ranges from I equal to 0 till the number of elements. So we read the numbers with the help of the function. We read the numbers with the help of the function next int, but now next int is called by the object random. So it is going to generate random numbers. The next int method has a index in it, a parameter in it, which says that the numbers read or the numbers generated by the PC should be in the range 0 to 9876. So all these numbers that are read will now be stored into the array, the single dimensional array. So then we simply try to display the contents of this array. After it, we'll record the current system time in the variable start time and make a call to the sort function. To this sort function, we are passing as input the array and the index of the very first element, that is 0, and the number of elements in the array. And once the control gets back to the sort function after completing the merge sort, we again consider the current system time. So we'll store it in the variable stop time, and then the next line is supposed to print the sorted array. So as we know, the maximum number of elements in the array is given by the variable number of elements. So again, by making use of for loop where I ranges from 0 to number of elements, we make use of sysout statement to print the contents of the array once they are sorted. and the amount of time taken to perform this sorting is again calculated by stop time minus start time, which is given in terms of milliseconds. So then the next class in the same program is merge sort. Merge sort has a member function called as merge, which takes four parameters. The first one is the array that you want to merge, and the next one is the index of the first element given by low, and mid is the index of the element that is at the location low plus high divided by 2, and then high is the index of the element that is situated at the other end of the array, that is the last element in the array. So then we have declared variables I, so I is assigned low value, j is assigned a mid plus 1 value, and k is assigned a low value. K is assigned a low value because we are trying to copy the elements into another temporary array, so we call it as result array. So we have declared another single dimensional array called result array here to store the sorted values in it, again with the capacity to hold 10,000 integer numbers there. So as we know in the merge algorithm, if the value of low is less than or equal to mid, that is if I is equal to less than or equal to mid and j is less than or equal to high, then we compare the elements in array of I with the elements of array of j. So if array of I is less than array of j, then we copy array of I into the result array k and increment I by 1 and also increment k by 1. Otherwise what we do is we copy array of j's element into the resultant array and then increment the value of j and increment the value of k. So once the copying is done, we come to the next while loop where I is less than or equal to mid. So I is less than or equal to mid means that we are trying to transfer the remaining elements in array of I. So therefore it is done with the statement result array of k plus plus, which is assigned values from array of I. So array of I plus plus each time. And similarly we still have other set of elements remaining or left out in array of j, so we also try to copy them. If j is less than or equal to high, then we copy the contents of array of j into the resultant array k. So then once the copying is done, we are transferring all temporary array elements into the reference array in line numbers 83 and 84. Followed by it, merge sort class also has a member function called as sort, which takes as input three parameters: the array that is to be sorted, and then the low value, that is the index of the first element in the array, and the high value, that is the index of the last element in the array. And we know that it's a divide and conquer technique, so it is going to split the arrays into two halves. So if low is less than high, then it calculates the value of mid by low plus high divided by 2, and then this merge sort class calls for the sorting algorithm, which is applied on the left sub array. So the parameters are array and then it starts from the first element by in the index low and runs till the value of element that is situated at mid. And the next line calls the sort algorithm on the same array but starting from the elements situated at the location mid plus 1 and shall range till the elements at the last position, that is high. And once both the sorting are performed, then we are going to make a call to function merge, which is going to join the contents of both subarrays that have been sorted into a single one-dimensional array. So to this we pass as parameter the name of the single dimensional array and the index of the first element, that is low, and the index of the middle element given by the variable mid, and index of the last element given by the variable high. So now let us see how this program runs. So it is asking us to enter the number of elements that you want to sort. So let me give a small value here. I want to sort only 5 numbers. So it is generated some numbers randomly like 3405, 2549, 553, 6296, 1719. So all are in the range that we had given the index value. It was something like 9876, right? So it performs merge sort and you can see that the sorted array here has the first number to be 553 followed by 1719, then 2549, 3405, and then 6296. So this is how merge sort works.